Alright, so they would like us to solve this system by graphing. This system of equations contains two linear equations. So to solve this system, we want to graph each equation, and wherever they intersect at, that would be the solution. So when we solve a system of equations that contain two lines, two linear equations, wherever they intersect at, that would be the solution. So to solve this by graphing, I need to first graph each line. So the first line is 2x plus y equals 9. I need to obtain two ordered pair solutions. Let's see. Notice if we were to insert 0 for x, if I were to plug 0 in for x, y would end up equaling 9. Right? So there's one ordered pair solution. I could then plug another number in for x, like 1. If I were to plug 1 in for x, it would look like this. 2 times 1 plus y equals 9. So I have 2 plus y equals 9. And after subtracting 2 from both sides, I get y equals 7. I now have two ordered pair solutions, and that's actually all I need to graph the line. You know, we could find more points, even like for example, if I were to plug say 3 in for x, you know, it looks like y would come out to be 3. You know, if you were to put 3 in for x, you could solve for y, you would get 3. But again, we only need 2. So on my coordinate plane, I'm going to graph 0, 9. I plotted 0, 9, and then I have 1, 7. Oops, I actually just graphed 0 and 8.5. It looks like, you know, every 2 markings on this coordinate plane is an integer, so I don't think I can erase that point I just did. It would be this point right there. There's 0, 9. And then 1, 1, 7 would be about right there. 1, 7. And 3, 3. Looks like it's about right here. And if I draw a line, oops. If I draw a line through those points, there's that line. Now I'm going to bring my attention to the other equation. The other equation is 2x minus y equals 7. And once again, I need at least two ordered pair solutions. If I were to put 0 in for x, it looks like y would come out to be negative 7. I'll plug 1 in for x now, and I'll work it out. If I put 1 in for x, it looks like this. 2 times 1 minus y equals 7. So I have 2 minus y equals 7. And then I would subtract 2 from both sides. And then I would divide both sides by negative 1. And so now I'll graph that line using a different color. 0, negative 7 is about right there. And 1, negative 5 is about right here. And then I would draw, and then I would draw a line through these points. Now, wherever these two lines intersect at, that's the solution. So that's the solution right there, the ordered pair. Now, when we solve a system of equations by graphing, it's inferior, in my opinion, to solving it using algebra, solving it algebraically. Because when we graph it, unless we're using a straight edge, it can be, we're using our eyes to estimate where they intersect at, and based on how sloppy or neat I draw my lines, where they intersect at precisely can be a little bit difficult to see. Now in my math lab, when we're graphing the lines, I think it'll actually be a little bit nicer because in my math lab, the graphing tool graphs the lines perfectly straight, and it's probably a little bit easier for us to see the solution than what I just did by hand. But I'm going to actually solve this system using algebra. It looks like it's set up for elimination really nice. Like here, I'm going to recopy the two equations. I have 2x plus y equals 9. And 2x minus y equals 7. Again, I'm going to solve this system using algebra. I'm going to use the elimination method. Notice what happens if I add the equations. If I add the equations, we get 4x, and then if I If I add the y's, they cancel out, and 9 plus 7 is 16. And then I divide by 4, so x is 4. Now I would take that and plug it into either one of the equations in order to obtain y. I'll use the top equation. Using the top equation, I have 2x. Oops, I'm gonna take 4 and I'm gonna plug it into x into that top equation. So I have 2 times x, that's 2 times 4, plus y equals 9. So 8 plus y equals 9. And so y equals 1. And so I now know that the exact solution to this system is x equals 4, y equals 1. And if we go over to the graph, notice that it's about, look on my graph, it looks like the solution is more like 4.5, 1 to me. That solution, that ordered pair right there where they intersect at, if I'm looking at it, it kind of looks like more like an x coordinate of 4.5, and then I guess it does look like 1. But that's probably due to me not drawing my lines perfectly straight, not plotting the points exactly correctly, accurately, because I'm doing it by hand. Again, in my math lab, when the lines I think will be perfectly straight, using the tool it'll be a little bit easier. But notice when I use algebra, it's easier to get the precise solution. So again, the answer to this problem is 4, 1. Now, imagine if we had a system of equations where the solutions were like x equals 4.3 or something like that. When you do it by graphing it using your eyes, it'd be very tough to see that.